Tomorrow we'll have a bit of a GOlang in the afternoon. So if you really get inspired today, you can also join tomorrow, and we'll start setting up the environment and do some hello world stuff.
Can anybody go that isn't really invited?
Yeah, I would say everyone can go who's interested in Go.
He's leaving, he doesn't care anymore.
I don't have to pay the bills anymore. Let's order pizza tomorrow. And in a few weeks we have a hackathon for the media tool, and also one of the things we want to try is trying some Go for that. So that's I think that's also an interesting way, because I don't know if you're going to mention like the use cases where it's interesting for, but already Dirk mentioned like highly parallel, low latency things. So concurrent. Please give a round of applause for Geert-Johan.
Right, so yeah, I'm going to talk about Go. A bit of background: I have been working with Go for over 7 years now. Started before the Go 1 release. Really enjoyed the language, so I thought I'm just going to dive into this, going to use this for some programs. And yeah, currently, so I'm working at the development support team together with Sebastian, the guy taking pictures over there, and it's been really fun. So what is Go? It's a general purpose language. It's compiled, so you actually have a compiler that's creating a binary for you, and then you can distribute that binary along. It's statically typed, which introduces type safety, makes the working environment quite safe to work in. It has built-in concurrency paradigms. We'll get into that later. It's very simple, so the syntax isn't very broad like C++, where there's lots of different ways to solve a single problem. With Go, there's usually just one good way to solve a problem, and everyone picks that way. So it's very easy to take someone else's code and start working on that. And that also makes it very productive, because working in teams, working on a single Go product, it's very, very friendly. You can easily take someone else's code and start working on that. It was originally created by 3 guys at Google. Pike and Thompson worked before on Unix and UTF-8, and these guys, worked at Google, and they wanted a language to solve the problems of Google, the scale that Google runs at. So they started in 2007. The first open source release was in 2009. And until then, if they wanted to add a feature to the language, to the specification, they all 3 had to agree. So there was a very strict kind of way creating this language. After it was released open source, over 250 contributors joined the project, and the work towards 1.0 release, which happened in 2012. And then in 2018, in this year, we got the 1.10 release. The thing is, with Go, if you build some software for the 1.0 release, it still works with any 1.x release. You can still compile it. There are no breaking changes. So that's also very important if you're going to start using a language. You don't want your code to break a year later when you want to compile it. So that's still going on. It's being used in a lot of projects. Docker is one of the most popular, I guess. Just heard a bit about it. Kubernetes, Influx, Ethereum BitCD, which is an alternative Bitcoin implementation. It's used by most of the miners in the Bitcoin network. Let's Encrypt uses it for their software server-side stack, as well as a reference implementation of clients. And it's used at huge companies: Google, BBC, Cloudflare, Sanoma, SpaceX. Those kind of companies really use Go. Let's actually dive into this. Let's start working on a small little project. What you got to do to start working in Go is install Go. Obviously, I have it installed on this laptop already. It's available for any processor or operating system that you're running. And then you need to test your installation. So we want to have some Go file. Let's open it here. Just some package statements. We're going to import the package, and we're going to write out a greeting. Let's just go run it. Go run hello.go. There we go. So the Go tool, it runs your code. If you use Go run and you give it a Go file, it will compile it and start the binary. It can also be used to run tests. So there's a test framework in the language itself. And it can also be used to build and format arbitrary packages. I'll get to the package structure a bit later. And the format tool is also very important. So Go code is always formatted for following a common structure. There's a huge consensus on, for instance, we're using tabs instead of spaces. Sorry, Python developers. Here you like spaces, but
I just confirmed it.
yeah, exactly. Yeah, let's get away from this topic very quickly. And then it can also be used to fetch binaries or code from the web. So, for instance, if I run go get github.com/Geert-Johan go matrix, it now uses Git to pull the source code in that repository, build it, and install the binary in my path. So I can now run go matrix, and we get the matrix on a very poor Beamer. So it's very, very easy to download the project, compile it. And this doesn't only work for binaries, but also for packages, libraries that someone else built. So for that to work, the Go tool needs a workspace. The workspace consists of 3 main folders: the bin folder, the package folder, and the source folder. Within the source folder, there's the whole structure. So you get, for instance, source/github.com/go/matrix, and then there's my go matrix source code. And this is basically where all the source lives. And then when that source is compiled, it gets either compiled to an object file, which is for a package, a library, or a binary file, which you can execute like go matrix. And there are no build files in Go, so it just needs the source files, and then it will know, well, we're going to make a binary, we're going to put it in that folder. So if you want to create a workspace, you just create the source folder and you set your Go path, which is an environment variable. I usually have my Go path to my home directory. A lot of people do that these days, because then you also have the bin folder in your home directory. You can just add it to the path environment variable, and everything you put in there is just executable. And then the namespace, so that's the import path where you put your code, which is inside the source folder. Usually you use either GitHub or GitLab or Bitbucket or one of those domains. But you can actually also use your own website. If you run Git on your own server and you have Geert-Johan.net, for instance, you can use that as the namespace. It's kind of like Java's com.java.whatever kind of packaging, creating a sort of ecosystem for code. So we can do that. I think I'll skip this one because we have more interesting stuff to get to. Because we want to build a nice little tool. We're going to build a tool to fetch the RSS feed of nu.nl, and we're going to use a package for that. We're going to parse it, and then we're going to print the headlines of articles and the URL on which we can read the article. So to do that, we're going to use the HTTP package to fetch the nu.nl feed. This is a whole lot. I'm just going to walk through it from top to bottom. So it starts with the package declaration, and any program that you want to execute, it is not a package, not a library. Starts with the function main inside the package main. So in this case, we have the package main as our starting point. Then we have some import statements, and these are actually packages in the standard library that we want to use. So log is for writing log output. HTTP is the HTTP client and server actually. It's inside that package. And then we're going to have our main function. So this is the entry point of any program. And the first thing we want to do is well, simply do an HTTP GET. We want to have the tag RSS feed, and it's going to return two values because Go actually has multiple return values. So we have the response, which is the HTTP response object. It contains the status, the body of the response that we got back from the server, lots of other information about the HTTP request that was just completed. And the second return value is an error. So if HTTP fails, for instance, there's no internet connection, then you'll get an error, and well, you have to check that error. Every time you get one error, you will want to check that. So that's what happens here. You compare the error to nil, and nil is like null, really. They just spell it differently. So if it's nil, then there's no error, and we can safely continue. If it isn't, then we want to print this error and quit the program. Then we want to check the status code because, well, HTTP 500 is still fed at HTTP, so it's not an error, but it is HTTP 500, so we're not interested in that. So you compare the status code. Well, is this a status? If not, again, return print an error and exit the program. And last but not least, we're going to copy the output of the response to the standard output of the program. So the copy function, you can see the definition below here. It accepts a writer and a reader. So the standard output implements a writer interface, and the response body implements a reader interface. So I'm going to get into the interfaces in a bit later. But that's basically what how copy is built up. So it doesn't really know what kind of reader or writer it's getting. It can be anything. It can be a file, it can be a network connection, it can be a DOF that you send up with a message and will return later. Doesn't matter, as long as it's implementing the reader interface or the writer interface, you're fine. So let's run this program. Luckily I have it in a file already. There we go. Got a lot of RSS, XML, gibberish stuff going on there. So this is not nice. I'm not going to read this stuff. It's very boring. We want to decode it. So to do that, we want to use a package because I'm not going to write an RSS parser myself either because I'm lazy. And we're going to use GoFeed, which is a package that's already out there. And this is just godoc.org, by the way. It's just a website, and you can put any import path, github.com/amcdol/gofeed in the URL, and it will fetch that and will create a package documentation. So it's a very extremely useful tool when you're working on Go projects. They always have documentation in the same spot. We see over here that there's a new parser function which gives the parser. Then there's a parse function which again takes an IO reader, so that's pretty useful, and that returns a feed. And then the feed has a lot of properties over here. You can see there's an items list which will give us the news items. So yeah, let's go ahead and use this. We're gonna replace the IO copy with the parser and getting the items out there. So first we'll want to add that import path in the import statement so that the Go compiler knows what GoFeed is in the next line. So GoFeed.new parser, obviously GoFeed refers to the import, and then new parser will give us that parser. We then use the parser to parse the response body, we get the feedback, and again, the second return value is an error, which you need to check. And then, in the end, we're going to iterate over those items and print them to the same output using a finish print line. So, you can see here the for range structure. Basically, the range structure says, well, on the right side I have a slice of something, which is like an array, and on the left side I have two variables. The first one is the index, so it starts with 0, And the second one is the item itself. We're not interested in indexing this case, so use the underscore to ignore that value. So let's give this a try. There we go. Bit multi-line stuff, but yeah, we get some nice nice lines over here. Looks a lot better than the XML that we had over there. So everything right now is in a single single file. It's not very nice, because usually you want to have some modularity in your code. You want to have functions, and those functions can be reused. For instance, if we want to have not only the tag feed, but multiple feeds shown in there.
Does the code stop executing if you call fatal or something, or is it?
Yeah. Fatal quits the program.
Ah,
Yeah, it writes the message, and then it's done.
Does it also download another package from GitHub directly while compiling, or?
This one.
Yeah.
No, I downloaded this before using GoGet.
Okay.
Yeah. So this one.
Yeah. Okay.
Yeah. Maybe I should have removed it before shown the error. But yeah. And usually, if you run GoGet without arguments inside a package, it will actually look at the import statement, see what is missing, and then download it. It's like npm install if you ever work with Node.
And then package versioning of dependencies, is it also, or are you going to talk about later?
Well, versioning is kind of a difficult topic. They've left versioning out of they've left versioning out of the Go standard tool. So there's like about 10 package dependency managers that people build right now. But there's coming next release, probably 1.11. There's going to be Vigo, which is the official Go team developed tool to handle this problem. It's going to be pretty neat, but it's you need some finishing touches. Yeah. All right. So yeah, we want to have some. We want to clean up the code a bit. So what we're going to do is create a get function, which we give the category a string. It's going to return a slice of articles and an error. And the article is something we also define ourselves. It's a struct type, and it contains two fields: a title, which is a string, and a URL, which is a string. And that's just to have our own nice little type to work with. We don't want to use that Go feed huge things pass around everywhere. So we need to change, we copy over the code from the main function. We need to change, of course, HTTP GET to use the category variable, so that we can use any like algemeen, tag, support, whatever, as a category to fetch the feed for it. And then we return multiple return values right now instead of logging, fatal logging. So either you return an error or you return the actual thing, the articles all the way down below. We add the body close, which is important because as long as you don't close the body, the network connection is still being used, it's still open. When you do that using a defer call, I don't know if Python has defer. Does it? Okay, so
I think in async I
all right.
Yeah, but you usually just open the session with
and then it does it.
So it's just
Okay. Yeah. So defer basically says, well, do this function call after we've returned from the get function. So if anywhere below the defer call the return is made, then the rest body close function is executed. In this case, we don't have an error which we can return, but we have the status code which we don't like. Because we don't like it, we make it an error. So the errors.new function converts any string into an error. And in this case, rest.status contains something like 500 internal server error or 404 not found. whatever the server sends back that isn't the 200. And then over here we're going to create the article slice. The slice is basically an array. The Python is arrays, right? Lists, okay, yeah. So that's basically the same thing. It can grow, it doesn't have a fixed size. In Go there are also arrays, but arrays are always fixed size. So barely use them. It's only for like low level networking stuff. So it's really interesting. So we're going to create an article slice and we're going to make it as long as the feed items that we have. And then we're going to iterate over those feed items and create an article and set it to the appropriate position in the slice. By the way, I'm using the item GUID over there. I found out that it's a shorter URL, so that's thought it would be nice to have a shorter URL in the terminal.
You're always returning two items, error and some response.
Yeah.
That's good. Is it convention or is it the requirement that you always return two?
Well, you only return an error if there's an error possible. So if there's a function like add, you have two integers and you add integers together. There's not going to be an error there.
So you can return whatever you want.
Yeah, you just return the integer.
It's like convention that you.
Yeah. But if you want your function to return an error, it's always the last return value. But yeah, you really define it yourself in the top line. That's the category, that's the argument, and then between the second pair of parentheses, there's the article slice and the error. You can have 10 return values there. You can have. You shouldn't do that because it's not nice, but you can have unlimited return values. Yeah. So you see 3 sometimes. Maybe felt very seldomly 4, but that's really when you're pushing it. You might want to wrap that up. So in the main function we change, we've got rid of the whole piece of code, we just then call get_tag, which gets articles, an error, and then we're going to loop over articles instead of feed items, and we'll print the title. Alright, let's run this one. There we go, it still works, nothing changed. Woohoo! Nice! Still got a boring list of stuff. So we want those links in there, because when we can't click this, it doesn't work, we need the HTTP links. So this is where we're going to use a stringer, because the func package, it knows how to format like integers and booleans and strings, everything that's built into the language. But if we've built our own type, like the article, then we can tell the func package how to print that out. And to do that, you have to implement the stringer interface. So I think Java has a very famous toString thing going on. The difference with interfaces in Go and, for instance, Java is that in Go, if you implement it, it's automatically you can automatically use it as such. You don't have to explicitly tell the compiler, hey, I'm implementing the stringer interface. All you have to do is actually create a string method which returns a string. And as long as you're doing that, you can use it as a string. So the func package will do the detection for us. We don't have to worry about that. All we need to do is actually create the string function. We're going to use sprintf, which is like a format thing that's using the 2 percentage hashes and extra arguments to position those. And then if you do a func print line with article, it will just use that function. The function again defines, well, we're going to first print the URL, then a dash, then a title, and then we can run that. There we go. All right. Awesome. So now we've got the list, and we can click one of these links, and then we can read the article, not accept the cookies. So then we want multiple categories, of course. So define a slice, iterate over the slice. We're going to print the category, the name, and then use that to the call to get. So then we should get a nice list. It's 5. There we go. nice list of much better. I tested it at home. I have like a widescreen screen at home, and then you don't have these problems. So we're gonna get a nice list with categories, and each category some articles. But I'm afraid that something terrible is about to happen. Pun intended. Because somehow, I don't know what happened, but somehow maybe something happened on UML, things got very slow, and we're going to get, it's suddenly, I don't know, doesn't make any sense. When we run this program, 6, it's going to wait a bit, print some, wait a bit more, and it's really slow, it's not nice. We want to somehow make sure that we can not wait 4 seconds, because if you're going to sleep for a second on every call to get, because the HP is slow, whatever, then you're going to wait 4 seconds if you do the get serially. So instead we're going to introduce some concurrency to make those 4 calls to get concurrently, aside from each other, and then we don't have to wait for each one of them. So to do this we need some concurrency paradigms. And Go has these built in, so they're part of the syntax. It's not a library that you're importing, it's actually the compiler that understands what concurrency is. And I have an example here. We have a simple main function, we iterate over 10 numbers, and then we call the print line function with the Go keyword in front of it. And this basically says, well, we're going to call this function, but we're going to call it on a different stack, a different thread, if you will. So we actually call them Go routines. And it's like a very lightweight thread. And you can have millions of Go routines in a single program without worrying about memory and such. So it just starts all these Go routines while iterating over for you. And then if you run this, you can see that like the order of numbers that are being printed, it's kind of random. There's no, because they're all running at the same time, so it's whoever comes first gets the print first. It's not anymore a serial operation. So that's the Go keyword, and you can do this with any function call. Any function call can be fired off as an asynchronous Go routine. Now when you do this, it's going to be a problem with get, because the get function call, it returns articles and error. So with the Go keyword, there's no way to obtain the return values. So we need some way for communication. And this is done with channels. So a channel is also a built-in type in the language. And you can make a channel by calling the make function. We're going to make a channel. And the channel transports something, in this case a string. It can be anything. It can be your own type, like our article, for instance. It can be booleans, integers, anything that you have as a type in Go can be pushed over a channel. And you can send on a channel, so in this case we're sending hi. And this is a blocking operation, so the send only is done when there's someone actually listening on the other side. And down below we can receive from the channel, so that's also a blocking operation. It waits there until someone has sent something on a channel. Well, that's like a point of synchronization. And then, of course, if we would execute this, the print line would print hi. So, to use this, we're going to create a getByChannel function. This function accepts the category and a channel of articles. We call it article channel, because that name sounded like it made sense. So, we're going to accept the channel. So we're going to run over, we're going to call the get function, and then if an error occurred, we're going to failure log. Otherwise, we're going to send those articles, which is the slice of article, onto the channel. That makes sense, right?
Yeah, so you said log fail exits the program. Does it also do that? Does it just kill the thread or the whole program?
Kills the whole program. Yeah.
So
In this case, it's a bit lazy, of course, but for the demonstration, I thought it would be good enough. But yeah, in this case it kills the whole program. It's not limited to GoToGroupToGo.
But there's something built in to deal with this in an actual live situation where you don't want if one of the threads is killed or for some reason that you can deal with it.
Yeah, now normally you probably wouldn't log fatal if just one component fails. Like if you run an HTTP server, of course, which we're doing with the channel, and one API call fails, then killing the whole server doesn't make any sense. So in those situations, you would actually have a log handler, which has something like Sentry in the backend. Send a log there, and then just exit this function, but you won't have to kill the whole server.
Okay, but that's these handlers.
Yeah. So the send operation over there, it's the smaller than the dash, sends on the channel. And then to use this, we actually need to create some channels. So in this case, I'm going to make a slice of channels. Each channel transports a slice of articles. And the slice of channels has the same length as the category. So we're going to make one channel for each category that we're going to fetch. And to do that, we're going to range over categories, make that actual channel, assign it into the channel slice on the correct position, which is I, and then fire off the go-routine, giving it its own channel to send on, and the category that we want to fetch. And then in the actual output part of the program, we're going to get the correct channel again and read from the channel. So the first bit, the get by channel, again, it's just fire it off. We're not going to wait for get by channel to actually start doing its work. It's just starting those go-routines one after each other until the full range iteration is done.
Can I ask something?
Yeah.
Why is there a difference between how Scholar double period is?
Yeah.
And the one with channels I is articles.
Right. So then the column equals, it's for new variable names,
Yeah.
like declaration and assignment in one. And just equals is for an existing variable. So just assignment.
Is it infers the types?
Sorry?
It infers the types and
Yeah.
it's strongly typed?
Yeah. If you make a mistake with typing, the compiler will just error and stop compiling. There's not even such a thing as compiler warnings in Go. The philosophy is if it's important enough to tell you about, then we're going to stop compiling. So it's quite strict, you could say. Even if you have a variable that's not being used, you can't compile. It just tells you, hey, you have an unused variable. Remove it, clean it up before you can continue. So it's very strict, and again, that makes it also very nice to work with other people, because sometimes people tend to be lazy and they leave stuff of code lying around and you don't know what it's doing, so you have to figure it out. So the strictness is you need to get used to it, but it's very nice actually. So we receive from the channel and assign it to the articles, and yeah, makes sense, I guess. Does it?
Yes.
All right. Let's see. There we go. We just had to wait 1 second because all those. Yeah. I see.
And if one of the Go subroutine is hanging, who's
Sorry, yeah.
if one of the Go subroutine is hanging, how is Go handle that? That he kills it or something?
Yeah. So Go has multiple threads itself, and it's multiplexing the Go routines over those threads. So it knows when a Go routine is being blocked. For instance, it's waiting for a hard disk or a network connection, and then it will get some other Go routine to use that thread. And it actually manages that very well itself. You can sweep it, you can tell it's like a number of threads on the operating system that it's allowed to use, but in most cases you don't have to do that. It will just detect the number of cores and threads that the CPU can handle, and then use that.
But what if the go routine just hangs?
It's infinitely waiting or something.
Then, for instance, you can have indeed race conditions where you have deadlocks, stuff like that. There is some deadlock detection which results in panics. Panics are kind of like the exception in Go. So there's that, but in some cases it can't really detect it because it may not know that something is never going to happen.
Well, what you can do, I don't know where your talk is going, but now it's blocking on the read. So where the highlighted line, which says the article, the Pascal-like assignment, and then the error reading from the channel, that blocks until that channel is killed. What you can do is put that in like a switch case statement, and have it say the first results in articles from that channel, and the second one is like a timer. So then it returns when the channel returns and you continue reading, or it returns when the timer fires. So they can have like really nice timeout mechanisms. Also for like machine learning, where you have like this really advanced model that might be congested, and you have this really nicely simple Bayesian kind of way, which always returns in 106, and you have like the default value, maybe the top 5. You can have, well, fire the really expensive model, see if it returns in 200 milliseconds, otherwise take the other one. Yeah. So that's like a really nice setup you can.
Yeah, because you can share the channels between Go routines, right?
Yeah,
now you definitely
yeah.
separate channels, but you can use the same.
Because now if this block, if the first one is taking 10 seconds, it would still wait on the first one to return, whereas like the other 9 are already returned.
So now the order is determined, but otherwise it could return in any order, basically.
Yeah, if you put them, yeah, exactly.
Basically just internal Kafka type of.
Yeah, exactly. Yeah.
All right. Let's see what else did we have. No, that was it. Yay! So the slides for this talk, as well as the code, is on GitLab. You can get it over there. Maybe actually create a CLI for nu.nl. I don't know if there's markets for that. Maybe there is. How about advertisement? I don't know.
You would not need the cookie bar. Which
exactly.
Actually is the most used Go service within Sanoma.
Yeah, I didn't know.
The third-party cookie consent is, well, it's even scarier than that. It's written by Jelmer and me. So that's a bit why that's a bit why we started this, because, well, to be able for you guys to maintain the stuff. You now have the basics, and all the stuff I did is not more complex than this.
Okay. Any questions?
Yeah. The most hated piece of
Is this lighter than any? If it's compiled and it runs a bit lighter than?
A lot. Yeah. It's very close to C speeds, especially when you're making use of concurrency, which is very easy to do. It's very cheap as a developer to add concurrency. They can beat a lot of programs. But yeah, it's native bytecode that goes directly to the CPU. So it's very fast, and it is garbage collected. So there's like a stop the world kind of thing going on there. But it's also very optimized in the last few releases. So it's actually being used for some game engines already, and that's garbage collection in games is usually not a good combination, but they're managing. So yeah.
Good idea for raspberries.
Yeah. There's actually a fun Raspberry distribution, which is like just a very lightweight Linux kernel, and then a complete userland built on with Go. And you can just get your functions written in Go, send it to the Raspberry, and it runs directly inside the userland of the kernel.
It's all GPIO can be
Yeah. Wrappers to yeah.
Same with containers. You can compile a container straight away.
Yeah, the unikernel project also is very interesting. Yeah.
Lambda supports Go as well, right?
Hey, awesome. Lambda supports Go.
Kind of fishy, but yes, it does.
Yeah, default now.
Oh, okay.
That's default. No, it's one of the supported languages. Yeah, okay.
Any other questions for Geert-Johan? No? Then thanks a lot. So, come talk to me if you want to join tomorrow's GOlang. Probably going to do something like this, just to get a bit of feel for it and get our feet wet. A volunteer came to me during dinner telling that she wanted to organize the next one. Maybe in a couple of weeks' time you should remind her of that idea and help her find speakers, help her arrange the food. Maybe do streaming, maybe not. Maybe that also helps getting a bit more people in instead of people at home saying that they're following it now. I hope this really lives on beyond me, and that not only the Go services that are there are my legacy, but also this, which was my 29th. Well, except minus the 2 that were organized in Finland without me and Jelmer, but hopefully this continues way beyond me. So thanks all for coming, and I'll be in the audience next time you organize it.
There's some little gifts for the speakers.
Oh yes, and we have speaker gifts. Also, you have to appoint someone to come up with speaker gifts, and then thank you. Thank you.
Olive oil.
And
Yes.
did I forget someone? Oh no, we got cancellation. Thank you. So,
I think, Sander, that we will consider you a speaker, and thank you to the bottom line and the workshop for all the things that you've done for the knowledge sharing in Sanoma in the past years.
Well, on that bombshell, it's time to end. Okay. Hey, thanks a lot, and until next time.
Sluit je toch weer af.
Ik heb hem op mijn laptop staan.
Nee, zet alles weer uit. Ja, dankjewel.